You're listening to a Frequency Podcast Network production.
We're used to being watched by now. Whenever you're outside your home in basically any public or private space, you're on camera. I mean, you're probably on more than one. And most of the world is familiar with the concept of facial recognition software. Programs that can pick a given face out of those reams of footage from hundreds or thousands of cameras. I mean, if you've ever watched a spy movie that's set in the last 30 years, you've probably seen it. There are valid arguments to be made about the use of that technology to pick faces out of crowds. But I think everyone could agree that in order to use facial recognition software, you probably need an actual picture of the face that you are looking for. Well, almost everyone can agree on that, because it takes just one enterprising investigator to bring evolving technology to a truly dystopian place. I'm Jordan Heath Rawlings. This is The Big Story. Dhruv Mehrotra is a staff writer at Wired. Hi, Dhruv.
Hey, thanks for having me.
Why don't you start with the murder of Maria Jane Wiedhofer, if I'm saying that correctly, and what cold case detectives were working with in that situation?
Sure. So Maria Jane Wiedhofer, she was 32 when she was found strangled and sexually assaulted at Tilden Regional Park. This is in Berkeley, California, or near Berkeley, California, and it was in 1990. So from what we know about this case, she went out for her routine jog in the evening and essentially never came back. The East Bay Regional Parks Police Department was the investigating agency in this case. At the time of the homicide, there were very few leads. Basically, it was some eyewitness descriptions of what they described as a suspicious man with a mustache, and then some DNA was found at the crime scene.
So there's not a lot, and as the years go by and nothing emerges, what did police decide to do?
Yeah, so the case had been cold for 30 years, and it's still cold, as far as I know. And over the years, the department had tried a few different things to try to solve it, but all of the strategies they tried came back kind of empty. So, for instance, they had run the DNA sample that they had on the crime scene through like genealogy databases to try to look for a match to see if they could find a relative of a suspect. And they didn't have any luck. They also tried, putting out a reward for anyone who had information. I think it was like $10,000, and no one came forward. So in 2017, as what appears to be a kind of, not like a last-ditch effort, but it is like a dubious strategy.
A shot in the dark, maybe.
Yeah, a shot in the dark is probably the right way to phrase that. But in 2017, they worked with a company called Parabon Nanolabs to algorithmically reconstruct the face of the suspect whose DNA was on the crime scene.
What does Parabon Nanolabs do exactly? I mean, you kind of just put it bluntly, but how does the tech work and what exactly can it produce and what do we know about it?
There's a couple of things here. The first thing is that the type of work that the East Bay Regional Parks Department contracted with Parabon for is called phenotyping. And it's not their bread and butter. It's sort of like a secondary offering that they give their clients when the forensic genealogy strategy doesn't work. So basically, like when DNA data doesn't have a hit in like a genealogy database, they'll then sort of as a shot in the dark, try this phenotyping strategy. So what that means is that the company has built this machine learning algorithm to predict an individual's facial features based only on their DNA. So the way it works is that the company had worked with thousands of research volunteers who took these volumetric 3D scans of their face with a camera. And then, they also provided their DNA data to the company. And the company basically ran all of that data through a machine learning model to train it how to correlate attributes in the DNA to specific phenotypes or facial features. So in theory, what they can do then is take a DNA sample from a crime scene and run it through this algorithm, which will then spit out this face. And it's a sort of crude face. It's like a, 3D rendering. It's a bald head when it comes out of the algorithm. And then, employees at the company use Photoshop and stuff to add in generic hairstyles or a mustache. That's what they did in this case. So it's this kind of wild process of high-tech machine learning alongside what is a sort of traditional and kind of forensic strategy of using, witness descriptions.
The wild part of this is only the first step in what we're eventually going to discuss police doing here. But first, just what do you do if you're the police with the face you get back? Like, what good is that really?
The way that the company intends these faces to be used is to sort of exclude certain suspects, right? So if the face comes back as a white male of, Eastern European descent with a few freckles, and they have a suspect list of a bunch of Black men with no freckles, then, this is supposed to be a lead, kind of a tool that they could use to narrow down the pool of suspects to focus their energies on, just the suspect whose DNA has, attributes that were found in the crime scene DNA.
It seems like, kind of an AI version, a computer-generated version of a witness sketch, really.
Yeah, and that's exactly what the company would say. It's like, a witness description or like a forensic sketch that's just informed by a bit more science.
But that's not necessarily all, at least in this case and possibly others, that police have used it for. So what else can you do once you have this phenotype sketch?
Yeah, so, in the case of the East Bay Regional Parks Police Department, the first thing they did is they published the image, published the face, trying to solicit leads from the public. And that already is quite controversial in that, these faces aren't particularly accurate, and we can talk more about why that is, but the faces aren't accurate. So they're already sort of like casting suspicion on a large part of the population that just might look like a forensic sketch. And then when that didn't work, they asked the Regional Fusion Center to run the face through facial recognition software to try to find a lead.
Okay, so you're now running a computer-generated face through a computer designed to recognize actual human faces. First, is that allowed?
It sort of depends on who you mean. Is it allowed by who? It's not allowed by the company Parabon Nanolabs. It's explicitly in their terms of service that these faces are not meant to be used for facial recognition. It might be allowed by the facial recognition vendor. We don't know what their policy is about, running these kind of composite sketches through their tools. Different companies have different policies that dictate what types of images their software is meant to be used for. But there are no federal laws, for example, about whether or not a police department can do something like this. So it's basically up to departmental policy and the companies themselves to determine, whether this is an appropriate use case for the tech.
You're now running computer scans of a computer scan. So I'm trying to figure out what you would possibly get back from this that could help an investigation.
Yeah, I think most experts I spoke to, or really all experts I spoke to, said that this just wouldn't work. At best, it wouldn't produce a lead, you wouldn't find a face. And at worst, it would result in sort of like a false positive match. These facial recognition algorithms are not tested on composite images like this. So
Right.
We really just don't even know what the error rates would be here. And, these are tools that, though they've gotten better over the last decade, there are still error rates that differ significantly between demographic groups, right? So there's a bias issue that can be introduced here, as well as just the general problem of casting suspicion on people who look like a computer-generated image.
What do we know about how accurate this computer-generated snapshot would be? I assume there are things that it will have that it must have because DNA, but beyond that, like all the other stuff that goes into creating a human face.
The faces are not accurate in the sense that you can't get an individual identification from a Parabon-generated face. But there are attributes of the face that they produce that are likely accurate. The sort of phenotypes that scientists generally agree can be predicted with DNA are things like skin color, the amount of freckles you have, eye color, and hair color. But when it comes to the shape of a face, the jury is out whether you can predict that with DNA. The science just really isn't there to support that right now. Frankly, Parabon Nanolabs is pretty measured about, their own claims of their software's accuracy.
So why would this tech even be used in that way then, particularly by police departments? I mean, I can understand if we are looking at the DNA to get, to your point, general descriptors, ancestry, complexion, freckles, that kind of stuff. And you could put that in a list to maybe check against witness descriptions. But if that's the case, what's the value of, especially the police, because now we're not talking for fun or frolic here, having the ability to create quote-unquote faces from DNA?
Well, I mean, the value to them, I suppose, is what you described. You can limit the pool of suspects. But certainly you can do that without generating the actual 3D model of the face. So frankly, I actually don't know what the value of the sketch itself is to a police department, other than, perhaps it's like a science fiction like tool that makes them make them feel like they're using some cutting edge technology.
What is this technology for, if not policing? Like, what did Parabon develop it for, and what is its ideal use?
Their main clients are law enforcement. So, it is developed specifically for law enforcement. The real use case is what we've said, which is to narrow the pool of suspects. So initially, the reason that the technology was developed was that the company got a grant from the Department of Defense to develop this phenotyping technology. The DoD wanted the tech because they wanted to sort of reconstruct the faces of people who built improvised explosive devices. Sometimes these IEDs had trace DNA left on them, so they wanted to try to see if they could recreate the face of the person who built one of these things. So they put out a grant for this in 2012, and Parabon pitched this machine learning solution that I described, and they won the grant. So that's really how the technology was funded and developed. But the use case was always to produce a 3D model of a face.
Where does it go after this, I guess, is my question. It's a long way to go from the police testing this stuff and trying to do it even though it's not supposed to be used this way and ending up in court. But, what happens if this keeps happening, I guess, is what I'm trying to get at.
I think it's likely to find the wrong person, right? Or to cast suspicion on the wrong person. It might lead to a false arrest. Facial recognition has certainly done this before. And generally, it just sort of speaks to this larger lack of oversight over how police are able to essentially daisy chain these law enforcement technologies together to cast suspicion on people. So I think that's the real problem that this is pointing to here. And, what law enforcement will say is that, look, we only use this stuff to produce leads. We always are going to follow up on the lead that a facial recognition search provides us. But the truth of the matter is that there still have been wrongful arrests this way. Mm-hmm. And, without any kind of oversight over how this tech is used, I think police will continue to use it inappropriately. And frankly, they've used facial recognition in similarly dystopian ways before. One kind of dramatic example here is the NYPD had a suspect in a case had looked like Woody Harrelson, according to a witness. So the NYPD ran a photo of Woody Harrelson through the facial recognition algorithm to try to, find a suspect. So, these tools they're not tested in the ways that law enforcement actually ends up using them. So that's the reason why we need oversight.
When you talk about this stuff with civil liberties advocates or people, who look at how the legal system works and you walk them through the double step that police performed here with these two techs, what's their reaction?
Oh, I mean, they range from like a face palm to a expletives. No one is happy about this. This is this is just not a good use of both tools. And we can talk about whether there are use cases that are that are useful for both of these tools, but combining them together is just such a red flag for civil libertarians, privacy advocates, and defense attorneys.
The last question, though, is I think we probably both agree that police are not going to just abandon either of these technologies because they're not quite perfectly accurate. And as well, technologies like these and others are only going to get better. Like, how will civil liberties advocates, sure, and police associations, sure, but the courts are going to eventually have to grapple with this stuff, right? Like, how do we prepare for where this is going?
The real check here is when evidence from one of these tools gets introduced into court, right? That gives the defense an opportunity to question the admissibility of the tool so they can do these admissibility hearings where experts will have to testify about their accuracy. I think educating, let's say, defense attorneys about the risks that this type of technology poses is a huge thing. I think judges are going to have to start to grapple with the error rates of the type of technology that law enforcement use.
Yeah.
But I think, even backing up a step, oftentimes this technology, this sort of lead generation technology, doesn't get seen in court, right? That's what gives cops the ability to, go to psychic mediums or things like that to try to find suspects. Like, that stuff doesn't have to show up in court. The only stuff that shows up in court are the sort of what results from the leads that law enforcement gets. So facial recognition, has I think only been challenged in maybe 2 court cases in an admissibility hearing, right? So I think this is a larger issue with this type of forensic technology, is that oftentimes it doesn't get that check of having to be introduced in court and having to hold up through the scrutiny of a judicial system.
If there's one thing the judicial system is known for, it's quickly adapting to emerging technology, right?
Yeah, that's exactly right.
It'll be, I was going to say interesting / terrifying to see where it goes from here. Dhruv, thank you so much for walking us through this.
Yeah, thanks for having me.
Dhruv Mehrotra, staff writer for Wired. That was The Big Story. For more, head to thebigstorypodcast.ca. Or get in touch with us by emailing us at hello@thebigstorypodcast.ca or call us and leave a voicemail, 416-935-5935. Joseph Fish is the lead producer of The Big Story. Robin Simon is also a producer on this show. Our sound design this week was handled by Robin Edgar and Christian Proholm. Mary Jubrin is our digital editor. Diana Kay is our manager of business development. Stephanie Phillips is our showrunner. And together, along with me, your host and executive producer, Jordan Heath Rawlings, we are the Frequency Podcast Network, a division of Rogers. Thanks so much for listening. Have a great weekend. We'll have a special episode for you on a holiday Monday and back to regular big stories on Tuesday.